In today's lesson, we are going to be looking at what types of values can we have. So this is section 113, and we're going to specifically talk about domain and range. So this is based off of lesson 112, where you worked with your graphing calculator to see complete graphs of functions and to determine what information was useful to describe those functions completely. In this lesson, you'll look at more functions, and this time you are going to be looking at specifically the input and output values that are possible. You will also learn about additional tools on your graphing calculator that allow you to see a complete graph. Remember to ask yourself the following questions as you work. What values are possible? Can we see the complete graph? And what other information can we use to describe this function? This lesson is pretty straightforward. So what you are going to be doing is you're going to go through this, make sure you read every single part, answer the questions on your packet, but make sure you go through every single piece that's on here. You're going to be taught domain and range, and what types of values you can and can't have. What I'm going to do is I will pop up the answers to this, so after you've gone through all this, double check your answers, make sure you didn't miss anything, because there might be a couple small little things that you'll miss. And then the last problem I will walk through with you. So go through 126, then go on and do 127, 128, and 129. For 129, I'm not just going to pop the answers up to this, I'm going to talk this one through, but the rest of them I'm just going to put the answers up. So make sure that you've gone through them, that you understand, that you've gotten them correct. So pause now and go through 126, 127, 128, and then 129. So check your answers now for 126, A through C, pause it. Here's D. Here's 127 and 128, pause. So for 129, now we're trying to get you to go the opposite direction. So now that you know domain are all possible values of x, so you look at your graph, you tell me all possible values of x, and your range is all your possible values of y. Now we're going to go in reverse, and we're having you sketch a function that fits the specific domain and range. Now here's the tough part with this type of a problem. It has to completely fit its domain and range. So therefore, if your domain says it goes from -3 to 10, it has to include -3, it has to include 10, and everything in the middle. You can't just go from 0 to 5. It has to fit all of those different values. And the same thing with your range. You also have to be really careful if it equals it or not. So sometimes it might not equal it. Do you remember what we do when it's just greater than? Greater than is an open circle versus greater than or equal to is a closed circle. So you're going to have open circles and closed circles depending upon what it is. So I know it has to hit -3 for x and it has to hit 10 for x. So what you might want to do, this is just to kind of get a good start on it. So it goes from -3 for my x values to 10. And it's up to you whether you want them to be dotted or solid. Some people like to do them dotted when they're not equal to and solid when they're equal to. Completely up to you. And then -4, so down here to 6. So what you have in essence is a box. So since these are all equal to, I'm going to just draw lines on there. So I need to be able to hit all sides of this box. So therefore, the easiest one to do, dot, dot, both of those have to be closed in, draw it in, and then get rid of the red. Or if you really wanted to, see how this hit this side, and this one hit this side and this side? Maybe you wanted to do start here, go up here, and then come down here. Now if you notice, did we hit all the sides? So this one and this one were hit with this dot, but this one was also hit with this dot, which is fine. And then this was hit with this one. Or we could bounce up and down. Again, ends being solid dots. So those are just all options of this. Now one of the things you have to be careful of is it has to be a function. So it has to pass the vertical line test. So I just got all the extra stuff out of the way. So make sure if you do the solid and dotted lines to kind of give yourself a barrier, erase those for your final answer because it is a function. It is just whatever fits that criteria. So now this has to pass the vertical line test. Infinite number of lines can cross through there, only crosses at one spot. This is a perfect one. Second one is a little bit harder. For the second one, it says the domain is all real numbers. So every single value has to be here, which means there has to be arrows on both sides. But the range, the y values, can only be at 2, 4, 5, and 8. So this is a very common answer I'll get from students. Does it hit my domain? Every single x value, right? Does it hit my range only at 2, only at 4, only at 5, and only at 8? Yep. Problem is, fails the vertical line test. It hits the graph in more than one spot. So this is not okay. So if you did this, pause it for a second and try to think through what you could do. If you've ever seen a step function, a possible answer for this would be a step function or a step-looking function. Now what you're going to notice is I'm going to have to put open and close dots because they cannot have 2 points on them, otherwise it's not a function. So now I can draw an infinite number of vertical lines. At every spot there is only 1 point that's in here. My domain and my range fit. So this one you had to be a little creative on. So this is just a symbol. So you're doing infinity. So x goes from negative infinity to infinity for your domain. The other option that you can do is for all real numbers is the all real number symbol. So it's 2 vertical lines and then a capital R through it. That means all real numbers. There's no other shortcut for writing all real numbers. Don't make up your own, it's wrong. So you can either do this for a domain that's all real numbers, or you can do this. Great job.